Differentiate 1 over x from first principle. Now, to differentiate that from first principle, what do you do the first step? You say, we have 1 over x, you say let y be a function of x, isn't it? So y is a function of x, meaning y is equals to 1 over. If y is a function of x, it implies y is 1 over. Then you move. For you to get to the gradient, you must have 2 points, isn't it? You must have 2. The first point, x1y, and the second point, x2y. For you to get the gradient, you must get 2 points. So let us start. How do you get x1? What is x1? You start from there, isn't it? So you start, x1 is what? So this point x1, y1, you can let it to be arbitrary point x1. So let the point x1, y1 to be xy. Then you now start getting all these values. Now start with x1. What is x1? x1 is just x. And you are done. Are we together? Then you move. What is y1? y1 is just y. Then you ask yourself, what is y? Everything must be in terms of x. What is y? Go back. What is y? 1 over x. You are now putting everything in terms of x. So you can see x1 is x and y1 is 1 over x. Meaning everything must be in terms of one variable. Let's see this scenario. Then you move again. What is x2? From the Cartesian coordinate system, it was x1 plus change in x to give us x2. Unakumbuka? If we had the Cartesian coordinate system, if here is x1 and here is x2, then between them there is some change in x. So x1 plus change in x gives you x2. So what is x2? It is x1 plus change in. Tuko pamoja? So it is going to be what? Substitute. What is x1? What is x1? Everything must be in terms of 1x. x1 is x. So here you get x plus change in x. You are done. Move on. Y2. What is y2? Somebody, what is y2? Huh? I'm better than y2. Huh? 1? Function of x. Don't be afraid. The day everybody has a doubt between their team. It is only. So what is it? What is that?
Function of x plus function of x plus
you are getting it, but now to be procedural, remember y is 1 over x, isn't it? Meaning if this is y1, y1 is 1 over x. Are you seeing? So y1 is 1 over x1, meaning 1 over x1, where there is x1, you put the value of x1, which is x. So y1 is 1 over x. Are you seeing the scenario? So it means when this is y2, y2 is 1 over. So you are now getting it. So y2 is now 1 over, because this is the function relating x and y, isn't it? Meaning if this is y1, that is x. x1. If this is y2, that is x. So y2 is 1 over x2. So what is y2? You put the value of x2. So what is x2? X plus. We've now determined all the points. x1, y1, x2, y2. We can now get to the gradient, isn't it? We can now determine the gradient. So what is the gradient? So the gradient is changing y, y2 minus y1 over x2 minus. Are we together? So can you now substitute where there is y2, put the value of y2, which is 1 minus x plus change in x. Then minus, what is y1? 1 over x, isn't it? So you're now substituting the values, everything is in terms of x. Then over x1, x2 minus x1, then you will always remain with change in x. The denominator will always be changing x. Then now, simplify the numerator. You can simplify that in a rough one. So if you simplify that, numerator, simplify the numerator. So remember, simplify the numerator. So remember, if you have a over b, look at this. If you have a over b, what is a over b? A over b is a times 1 over b. Are you see that? So this one means you have 1 over x plus change in x minus 1 over x. Then it is times 1 over change in, because it is divided by change in x, meaning it is times 1 over change in x. So you separated the numerator and denominator. Meaning numerator divided by numerator is the same as numerator times the simple of the numerator. Isn't it? So can you now simplify the numerator? You can now see it clearly. Simplify this cross multiplication. Are we together? This times this, isn't it? This times this to get the LCM. That is x plus change in x. We are simplifying the numerator. This times this gives us the LCM. Are we together? Then cross multiplying x times 1, x minus. You know you have to put that in bracket because it is for simple term. If you don't put in bracket, you automatically get the wrong place. So you have x plus change in x in bracket like that. Or you can say x plus change in x goes here how many times? It goes x times. X times 1, you get x, isn't it? Then minus x goes here how many times? X plus change in x times. X plus change in x times 1, you get that. So you have to bracket it because it is 1 time, isn't it? Then now open that bracket, then this one is times 1 over change in x. Higher. Move on. Open this bracket. Open it. X negative into positive. Are you seeing the importance of that? If you mess there, you get everything wrong. Okay? So negative into positive is negative change in x over x into x plus change in x, then the whole of that is times 1 over change in x. You see, I'm only doing this because I'm explaining. But in exam, you don't need a lot of unnecessary steps, isn't it? Those steps are very unnecessary, just wasted your time. So from here, x minus x, you get 0. So what do you remember in the numerator? Negative over x into x plus change in x, then it is times 1 over change in. Then see change in x cancels with change in x. See this one cancels with this. So what do you remember? In the numerator negative? Yeah, negative 1 over x into x plus change in x. You found that is the gradient, but we don't need the gradient, we need the what? The derivative, Are we together? So what is the derivative? Then it implies the derivative dy over dx is the limit as this small change in x tends to 0 of the gradient, isn't it? Are we together? It is the limit as that small change when it tends to 0, meaning you are getting a derivative at exactly 1 point, isn't it? So the derivative as this small change tends to 0 of the gradient gives you the derivative. The gradient is change in y over change in x, but the limit as this small change tends to 0, then it tends to the derivative, dy over dx. Are we clear? So can we now do that? So it means dy over dx is limit as small change in x tends to 0, then put the value of the gradient. What is the gradient? Negative 1 over x into x plus change in x. So for us to get rid of limit, what do we do? If you get rid of the limit, it means where there is change in x, you put 0. Are we together? If we want to get rid of this limit, it means where there is change in x, we are going to put 0. Okay? So it means when we remove limit in the numerator, we remove with negative 1 denominator, we remain with x into x plus 0. Meaning when we get rid of the limit where there is change in x, we put 0. And we got rid of the limit. So what do you get there? Negative 1 over x plus 0 is x. So x times x, you are done. Just like that. You differentiated the function from first principle